Welcome back to GATE Big Data and AI Forum. This morning we had a lively opening session with high-level officials. Then we have two panels. The first one was Big Data and AI, where we discussed the sharing data, the talent, the new skills the data science engineers need, and very interesting discussion. The next panel was on Digital Twin City, where our partners and collaborators shared experience about how some useful use cases and how they did this in different parts of the world. Now we are moving to the next panel, which is on digital health. And I would like to introduce the moderator of the panel, Dejan Paležev, who is from GATE Institute, leading this direction, future digital health. And he has a Master Science from Mathematics from Sofia University, then PhD in Yale. And 5 years ago, he returned in Bulgaria and was leading a data science team in one of our big organizations. And just last year, he joined GATE. And now he'll moderate such interesting panel. Dejan, the floor is yours.
Thank you, Professor Ilieva. So, couple of words about this session. The goal is to discuss different elements of the process of gaining insight and applying that insight in the domain of digital health. Particularly in this year, there is no need to explain the importance of the digital health and the healthcare domains to people. And obviously, no single organization can contribute alone to the innovation of in this domain. And there are many different organizations of different types that are helping the advances in the health industry and in the digital health. So the goal of today's session is to give you perhaps not an insight, but just a glimpse of the collaboration between the different types of organizations and the different stakeholders that exist in the field. This would be biomedical researchers, hospitals, medical doctors, people with technical skills in data science, biostatistics, bioinformatics, smaller companies, startups, and of course, the industry. And for that, we're going to have participants from different fields that are related to this domain. That includes the ecosystem, of course, industry, academia, healthcare providers. And now, without further ado, let me introduce our keynote speaker, who is Professor Dr. Milan Petković, who is the Vice President of the Big Value Data Association. Professor Petković.
Thank you, Dejan. So thank you for inviting me to give this keynote. Let me also share my screen because I prepared a few slides. I hope you're getting my screen. Yes. Indeed, it's a great pleasure for me to participate in this symposium and talk about opportunities and prospects in digital health, and as well as the importance of data and AI technologies in this transition of the healthcare sector. I'll start with a simple message. Basically, we need data, we need AI algorithms in order to improve our health, and I hope I'll be able to explain this to you in a few slides. First of all, a new era of healthcare is emerging, the era in which people increasingly take ownership of their health and their well-being. Supported by industry, supported by healthcare sector, public sector, etc. For Philips, this is Philips is a company with a presence in both the personal health as well as professional healthcare worlds, and this presents a real opportunity to continue what we have been doing for 125 years, which is creating meaningful innovation that improves people's lives. So at Philips, we set to ourselves an ambitious target. We want to improve lives of 2.5 billion people by 2030, and by making the world healthier and more sustainable through innovation. That's our main goal. That's just to give you a bit of a context where I come from and what the view of a company on this space is. Now I'll focus a bit on the first of all, the trends in healthcare, again, to just give you a bit of a bigger context of why we believe that digital innovation in healthcare is so important. There are 4 trends nowadays in healthcare which drive this need for innovation. First, more and more people are suffering from chronic illnesses. Second, we expect from our healthcare systems better healthcare, better patient outcomes, but we also don't want to pay a lot. We want to have this for lower cost. Third, we as citizens, we want to take control of our health as well as healthcare. So if we get ill, we are taking more and more control of that. And finally, healthcare sector is undergoing digital transformation, and that digital transformation results in a lot of data that is created, which also is a big opportunity. So I won't spend a lot of time on first 3 drivers. So just want to give just to make sure that I bring it to your attention that one of 3 of us would get a sort of, cancer, unfortunately, and that cancer is becoming a chronic illness more and more, because it's not, in most of the cases, you need actually to treat these people longer. 1 billion people are estimated to have hypertension, which leads towards cardiovascular chronic diseases. So it's a big group of people that we need to take care of. On the other hand, we are spending a lot of money on healthcare systems. 10% of GDP in European countries is spent on healthcare. With that trend, in 2050, I think we'll be spending 50% if we continue rising the healthcare cost as that goes for a couple of years. So on the other hand, we see, especially now in pandemic, that there is a lot of problems with the healthcare workforce, and we need to help these people so that they can actually do their job properly. As mentioned, many people are looking now into their own health and would like to take control. So that's another trend. But I'll focus mostly on the last factor, which is maybe not so much driving the need for innovation in healthcare, but is actually providing opportunity. And that's this data, because this digital revolution that we had started, that creates a lot of data. And you can think of, lifestyle data created in the lifestyle setting, where we collect a lot of data about activity that we have, or we measure certain vital signs. But then you can also think of a lot of data that is created in the healthcare sector, electronic medical records, etc. So this growth rate of increasing the data in healthcare is 50% annually, which provides a big opportunity. So how quickly is this digital transformation happening in healthcare sector? So a year ago, we would probably say that can be done faster. But now with COVID, we've seen dramatically that this accelerated actually. COVID brought us a new reality where quickly, we really need to get all this. So we see a lot of people that started actually using this virtual care services. They accepted those things because they are safer. It's much safer to have a consult from a distance if you can solve the problem in that way. And we've seen very much the importance of the sharing of data, which I'll talk about in more detail. This slide depicts the healthcare continuum. It starts with healthy living, it goes to prevention, diagnosis, treatment, home care. If we have relevant data for each of these phases, and if we can put all these data together, that can obviously help us to create new medical knowledge or create insights about the health of the patient. This data will allow also companies like Philips to create innovation, because having access to these data help us to understand and apply AI algorithms to actually address the needs that the customers have, the healthcare providers have, the patients have. So, and then let me talk about some of the challenges and some of the ways forward. We believe that putting data, AI algorithms, and clinical knowledge together, if we put these three together, that we can create actually AI-enabled solutions which can address these needs of the healthcare sector, which can improve the outcomes, patient outcomes, provide lower cost of healthcare, help actually healthcare providers to deal in a much more efficient way with patient and their job, as well as to improve patient experience. And by combining AI algorithms together with clinical knowledge and data, we can ensure that actually these features or functions that we provide to healthcare providers or patients, that they are in the right context, that they understand actually what is the context of the patient, where is the healthcare provider, they can adapt to this context, and they can integrate very well into workflows and address the real need. So let me give you a few examples. How can we turn data, AI, and clinical knowledge into value? And I'll start with a very recent example, focusing mostly on the data part and the pandemic, because this pandemic taught us some very important lessons. First, about the importance of data sharing. And secondly, that still we need actually to make further steps to improve this data sharing in the healthcare sector. There are great examples, and this is one of them, which is from the Netherlands, where Philips, together with the Dutch government, actually created very quickly a national portal to exchange COVID patient data in the Netherlands, because obviously, as in the other countries nowadays is happening, we had to move patients from one hospital to another to make a sort of, to balance the load on hospitals. And then it is very important also, together with the patient, to send the data, not obviously in ambulance, but to ensure that there is an infrastructure that the hospitals can actually share data of these patients and ensure that there is a proper handover of the patient from one hospital to another hospital. There are also very nice initiatives from European Commission, like COVID-19 data platform, Vodan initiative, etc. But still, we are not yet there when it comes to sharing of health data. There are lots more steps to do. There is data sharing across member states in Europe and further on. So, however, maybe it's most interesting to look at the elements where we put together actually the AI algorithms, data, and clinical knowledge. I will just give you one in the next slide, and I brought this slide just to show to you that in Philips we are maintaining a transparency page which lists all AI-enabled propositions. And you can, if you're interested, you can take a look into and read more about those. Today, I'll just mention one, just to give you a feeling what is this about. This example is about detecting early signs of patient deterioration in general care setting. It is a product called IntelliView Guardian software, and it's running into it's actually in a general ward in hospital, and it's meant to it is meant to basically help doctors to identify whether a patient is getting into critical condition. And you might know that in intensive care unit, you will have a lot of vital signs measurements, and then you will have a lot of alarms. If certain vital sign like heart rate or blood pressure goes above certain threshold, then there will be an alarm. This system allows you to actually predict that this will gonna happen. And how does that work? It works based on historical data and the outcomes of the patients. So basically, with a lot of data and good AI algorithms, we are able to create models and predict that in an hour or in 2 hours, that particular patient will actually get to the critical condition, and then give time to healthcare providers to basically do an action and ensure that the patient does well. And that obviously in studies, and you can see on this slide, gives lower mortality rates, lower ICU readmissions, which saves a lot of cost, etc., etc. Then maybe to also bring to your attention a European project that you might have heard of, which is in a data PPP. It's called Big Metalytics. And the goal in that project was basically to bridge the silos between healthcare providers, between hospitals, between health tech industry, between pharma and payers, which are in many cases insurance companies, with the main goal to unlock the value of data that is collected between these silos and demonstrate the benefits of how this data can actually be used to address these challenges of the healthcare systems that I was talking about. So project is finishing in August next year, and is already proud of many achievements along the biggest healthcare challenges. Improving patient outcomes, facilitating this unlock of and the value of data, looking at the data quality, improving productivity, etc. So I encourage you to check the project pages and look at it. Finally, I would like to address the biggest challenge with data. I already mentioned the challenges with respect to AI, which for me is to bring basically AI to the next level, to combine data-driven approaches like machine learning, deep learning with knowledge-driven approaches, and by that also broaden the space from narrow AI to more wider AI, and hopefully long-term in the future to general AI. But let me finish by talking a bit about some data challenges. So first of all, in the healthcare space, all of us, I think we all welcome the European Commission initiative to create common European data spaces, because we believe that data sharing provides a really necessary basis to tackle the biggest healthcare challenges we face nowadays. Still, as I already mentioned, there are European action needed actually to ensure cross-border challenges, so that we can share the data cross borders, to also to align all regulation in Europe related to sensitive data like healthcare data, so that we can basically are able to have one single market. The creation of a common European health data space in which health data information is exchanged cross-border, and which enables the participation of all the stakeholders that were mentioned also by Dan and myself in this ecosystem, I think it's a big priority. So I would like to finish with a few challenges and maybe also some recommendations. So I think first it's very important to unlock the value from data, which is held by public sector. There is a lot of data which is collected in hospitals, by healthcare systems, and the ability to harness large volumes of this data and use AI with this data will definitely accelerate innovation in Europe in the healthcare sector. Secondly, I think we should make it easier for individuals like ourselves to share data for public good, health data, donor the data, basically. So I think if we are able to facilitate such a process, that we can also get it going, and obviously by raising awareness of how that will benefit all of us, how that will benefit the society, ourselves, our family members. Thirdly, I think we should prioritize standardization needs, improve data interoperability. And then finally, I think we need to ensure that our organization and infrastructure for data sharing is at the right level. So there are a number of initiatives like Gaia-X that could be instrumental in bringing that process. Also, the European public-private partnerships can play a role, but it's important to address this. Finally, I would like to bring to your attention an upcoming public-private partnership of AI, data, and robotics, which is initiated by Big Data Value Association, Claire, Alice, EuroAI, and EuroRobotics. If you're interested, please join us so that we can successfully shape the future of Europe. Thank you for your attention.
Thank you, Professor Petkovic. If I may ask you just a quick question. Obviously, you have a unique perspective in the field due to your affiliations with the industry, being Philips with the Big Data Value Association, that kind of covers the ecosystem and also in academia, so that you can see the domain from many different points of view. And you already answered part of my question about the challenges, but also I would like to ask you, what do you think was the biggest improvement in collaboration between the different stakeholders over the past several years, or perhaps even this year? You mentioned that many things were accelerated by the pandemic. So yeah, what is going on well, and what has improved the most significantly recently?
Yeah, thank you for your question. Yeah, so I think during last years we identified, actually in many cases, the value that can be created by putting this data together and by having collaborations between different stakeholders in healthcare sector. We've seen in the past, for example, a lot of hesitation between hospitals and insurance companies, so that they don't want to share the data because hospitals are worried that insurance companies will stop funding certain activities they have, etc. So, however, if there is a win-win, and they can actually, in these public-private projects, they can see actually the benefit of sharing certain data, or sharing the data in a way that you're not disclosing everything, that basically the value can be created for both. And the same is also, I think, that we would need to do with citizens, because we don't want to go in the direction of, that some big maybe companies from the West are doing, that they are in most of the cases actually asking you as a citizen to share the data, otherwise you'll not get the value, and then there is no other choice. But if we raise enough awareness of a win-win situation between patient and as well as the research population and healthcare, as well as industry, that they might be actually willing to share the data. And I think this part we still need to develop further. I think we're already in the industrial sectors already getting connections, and there is more connections between healthcare providers, industry, but with citizens, I think we could still improve, and we can still raise awareness and facilitate this data sharing, so that that basically, all the people in academia that are working, researchers in this sector, can actually get access to more data. And by having access to more data, then they have a chance to improve healthcare by just bringing new innovation in.
Thank you. Thank you very much for the insightful presentation and overview of the state of the digital health domain in Europe.
Thank you for inviting, and I wish you a successful panel.
Okay, so next I will say a couple of words about what we do here at Kate. So, as Professor Ilieva mentioned, we started the unit that does research in the digital health domain several months ago. We are still a small unit, but we are looking to expand. And the overall goal of our activities is to design and apply machine learning and artificial intelligence methods to all sorts of biomedical data and solve the related problems. In addition to machine learning and artificial intelligence, we have an expertise in, let's say, more traditional fields as bioinformatics and biostatistics. Being a big data institute, our main projects are related to a type of data that is really big data, and this is the next generation sequencing. So the next generation technology provides many millions, in some cases hundreds of millions of so-called reads or sequences of DNA or RNA base pairs or nucleotides. And the good thing is that the technology is getting cheaper and cheaper, and that the output is getting larger and larger, so we can gather much more insight with that data. Based on the next generation sequencing data, we have two main projects that we're currently working on. One of them is what we call Omix type of analytics on Alzheimer's data. So the purpose of this is to use next generation sequencing data to create segmentation of patients or potential patients, and also to try to predict the decline in the cognitive function of those patients. And again, given our expertise, here we would use various robust artificial intelligence, machine learning and deep learning methods in order to be able to develop those models. And this is a joint work with colleagues from Chalmers and from Yale. You'll see a little bit about that project later on. Also, we're working with colleagues from Stanford on detecting complex structural variation events in several thousand individuals. Also, we are improving one of the existing methods for prediction of particular types of F events that is based on machine learning. Also, in addition to these main projects, we do what I call consulting work for other colleagues in academia and also some startups in the industry. We analyze data from apps that collect biomedical data, or also from connected devices. And now let's continue with our panelists. The first one is Dr. Rosen Dimitrov, who is a vice chair of the board of the Digital Health and Innovation Cluster in Bulgaria. And as such, he will tell us a little bit more about the Bulgarian ecosystem that his cluster represents to a major part. Awesome.
Thank you very much, Dan. I have prepared a short presentation just to introduce our organization representing the digital health and innovation ecosystem in Bulgaria. So our cluster organization was created 2 years ago, just after the Bulgarian presidency of the Council of the European Union. And it was inspired by the words of Roberto Viola, representing the European Commission. He was here in Sofia during our presidency, and he participated, he took part at the Digital Assembly. And he said a couple of things that made us think about how we could make things better. So he said that Europe is going for a data-driven healthcare system, which is something very, very different from things that were previously done. And he said also something very important, that this data-driven healthcare should not be some state control enterprise. In fact, he said that it's very difficult now for states and governments to move to this data-driven healthcare. And this could be done only by means of an ecosystem that is open for private entrepreneurs who provide these tools that create value out of the vast technological and data resources. And based on this, 2 years ago, we created the Digital Health and Innovation Cluster Bulgaria with a clear vision that we need a sustainable and effective healthcare system based on data and technology. And the way that we want to achieve this is by means of this ecosystem, by creating an ecosystem, by developing this ecosystem. It sounds like a buzzword, you know, an ecosystem, but we saw that in these 2 years, this could be done. And now you can see that in our organization, we have more than 30 companies and organizations, members of the Digital Health and Innovation Cluster. We have big pharma companies, we have big IT companies like Microsoft, like VMware. We have big Bulgarian IT companies like BGO Software, like Ontotext, for example. We have smaller companies, but very focused on telemedicine, on data, on predictive analytics. Companies focused on electronic health records, on cybersecurity. We have also serialization in production. We have also non-government organization, especially the patient organizations are here, the organizations of physicians and pharmacists. So in fact, we have all these different stakeholders that are part of our ecosystem now. And this is just 2 years later. And now, in the next couple of months, we will have even more companies applying to join our cluster organization. And what do we provide as a cluster organization? We saw that it's very difficult for the companies to enter the healthcare system, especially if they don't have expertise, but they want to change something. So the first thing we provide this is access to up-to-date and timely information, access to business information for them. Also, we provide support and development of their digital solutions they want to provide for the system. We serve as a platform for collaboration, and we provide also mentorship in healthcare and educational system. And in fact, our cluster organization performs the role of an ecosystem orchestrator. And here you can see how it works. We are giving this value proposition for effective and sustainable healthcare system based on data and technology. We work with academia, we work with the university in Sofia and with the second biggest university, which is the one in medical university, which is the one in Plovdiv. And in fact, the ideas come from academia, but we want these ideas to go further, to go to prototypes. And that's why we supported the creation of the pre-acceleration program, which is called Beyond. It was created together with Junior Achievement Bulgaria. And in fact, in this pre-acceleration program, we move the ideas of these young people to prototypes, and some of them move to startups, and these startups enter our ecosystem, they enter our cluster. And what we saw from our European experience, that cluster organizations are widely supported across the European Union in different programs. And we got in touch with other cluster organizations from Austria, Germany, Spain, and we see that this model is working quite well, because cluster organizations are a good way to have all different stakeholders on board, and by different business models to move forward in terms of digital transformation of healthcare. And I will also share with you the main strategic topics that we work on in our cluster. Of course, we start with patient as an active partner, all different solutions for the patient engagement. We move to prevention. In fact, prevention is the main topic and the first starting point. Everything connected with knowledge on time. It was discussed in the first presentation, all that data and how we could create different solutions, predictive solutions on this data. Of course, all these should be done as an ecosystem of services and different components, not to stay in silos, but to work as a common ecosystem. Of course, everything should be done with all cybersecurity standards. And at the end of the day, what we want to achieve from all these different types of digital health solutions, they should reflect the public health in general. Thank you. This was my short introduction. And if you have any questions, I'm open to answer.
Thank you, Rosen. Indeed, we will follow up on some of the stakeholders that you mentioned in the digital health domain so we'll follow up at the end of the session. And now let me introduce Frederick Johansson from Chalmers University of Technology, who is one of our collaborators, and I believe that he would talk not only about our collaboration, but also his other successful collaborations within the domain over there in Sweden. Frederick.
Thank you so much, Dion. Yes, my name is Frederick, and I work in the topic of AI and healthcare. I'm an assistant professor at Chalmers University, as Dion mentioned, specifically in something called the Data Science and AI division, where almost all of us work with machine learning or AI in some way, and a lot of us work on applications in healthcare. And as you may already know, AI and machine learning is making its way already into the healthcare space through a lot of different types of functions, and some of which we've heard about already in the other talks. For example, in diagnosis, AI systems are used to find problems in X-ray or other kinds of tomography images. AI is used in smart records to improve record keeping for clinicians, so they don't have to spend as much time on it. It's used in monitoring so that we can figure out if a patient needs urgent care, and in decision support to figure out how should we treat a patient in front of us right now. And these are not just interests of mine. It turns out that at Chalmers, the interest in these kinds of questions in health and how we can improve health through various kinds of engineering or technological research that interest spreads across almost all of the department at Chalmers. What I'm showing here is a survey done last year to gauge how many would want to work on health-related topics. And it seems like in almost all departments, 5 to 10% of researchers at this technical university want to work with health or are already working in health-related topics already. I wanted to highlight just 2 initiatives at Chalmers that I'm involved in varying capacity. The first one being the Chalmers AI Research Center, or CHAIR, which is this university-wide center that is supposed to promote and support research internally, but it also has a consortium of external collaborators, including, for example, the local hospital, but also companies like Volvo and others. There's also something called the Health Engineering Area of Advance, where which again is an initiative that spans the university, but here the focus is not only on AI. This is in general, how can we use engineering research or technological research to improve health in some ways. So I mentioned already that one of our more important collaborators within this CHAIR initiative on AI is the local hospital called Sahlgrenska University Hospital. And this is not just one, it's actually a system of 4 different hospitals in the Gothenburg area, which is the second biggest city in Sweden and its extended region. So this system of hospitals have more than 1 million visits from patients per year, which of course generates a lot of data that we could analyze in different ways. And it turns out that this is already being done a lot at the hospital, to no surprise perhaps, that more than 50 AI research projects are already going on at the hospital, some in collaboration with Chalmers and that I'm representing, but some with other collaborators as well. So since there is such a common and large interest between Chalmers and this hospital in these kinds of questions, AI plus health, a steering group was created to try and coordinate research across these 2 institutions. And I'm part of this steering group, and we work to, for example, create joint events, to educate one another, perhaps have dual affiliations and guest professorships and that kind of thing. But more concretely, one of the things that we've worked on so far is to develop a joint research agenda for how we should perform AI plus health research in Gothenburg. And of course, there are many aspects of health and AI research that could be covered by such a thing. For example, on the very extreme end of our side, or the technology side, we have the theoretical analysis of AI systems. How should we understand theoretically what learning systems or statistical systems do? And then we have the other extreme of the health side, where we care about deployment and actually clinical use of the products or the systems that we developed. And in between, there's a whole range of different activities where we can collaborate to make sure that we spend our time wisely. For example, clinicians could impact what theoretical questions we study because we want them to be worthwhile long-term. And in reverse, we could affect clinical deployment by building systems that have theoretical guarantees and so on. So this is the temporal perspective of AI research that connects to health, but we've to try and limit a little bit what we do in collaboration, we've also identified a few focus areas where we think our current and historical activities as these institutions could help sort of the most and to have a largest impact in the shorter term. And these are fairly broad areas like diagnostics and monitoring. Chalmers is very strong in image processing, which is a huge component of AI in health currently. But we also are interested in things like administration and how to run the hospital in the most efficient way. How should we do prognostics to figure out where we need more resources and so on. AI systems and governance refers to things like software engineering and building robust and reliable systems, but also ethical considerations. How should we deploy AI in an ethical way? Diane already mentioned one example of a collaboration that we're doing with GATE, but it turns out that this is also a collaboration with the local hospital. And that one was on Alzheimer's disease. And in particular, we're wondering and we're looking into why it is that some patients who have developed certain indicators of Alzheimer's, why do they progress quicker than others? why is it that some patients deteriorate much quicker in their cognitive function than other patients who remain much more stable for longer? So this started as a collaboration between Sahlgrenska University Hospital and Chalmers, and here we are looking at, for starters, just data that is collected publicly from other institutions, but we're hoping to move towards something that we can implement clinically at the hospital here in Gothenburg. I won't spend too much time talking about the GATE collaboration because Diane already mentioned it, but there are 2 projects that are going on already together with me and other researchers here in Gothenburg, but also Diane himself and other researchers at GATE. And in one of them, we look at the Omix side of this question. How can we identify genetic markers or more complex patterns from genetic information to try and predict who will progress more rapidly in Alzheimer's disease? And in the other project, we're looking at a different aspect, which is if we are supposed to use this system in practice, if we want to predict progression of Alzheimer's disease in a clinical setting, and so we can use these predictions, we want to make use only of data that is available readily in the hospital. We would prefer to use data that's routinely collected. And of course, that means that we can look at what is missing in data currently, what is being recorded in hospitals now, and try to make the best use of that information. I think I'll end here and thank you for your attention. And this was a very brief overview of AI and health research at Chalmers. Thank you so much.
Thank you, Frederick. And I should mention that imputation or the filling in of the missing data is indeed an important task that is to be done with biomedical data, because often there is a substantial amount of data that is missing, and we do not want to discard useful data just because some of it is missing. And last but not least, let me introduce Dr. Todor Kunchev, who is a neurologist at University Hospital Sofia Med, and as the name suggests, it is in Sofia, Bulgaria here. He will talk a little bit about another collaboration that he has with GATE in the field of cognitive diseases. Dr. Kunchev.
Thank you. Just let me share my screen as well. I hope you see my presentation.
Not yet. Yes.
Yes. So what I'm going to briefly present the CogniTwin project, a GATE project that we are doing in collaboration with the Faculty of Mathematics and Informatics at Sofia University and with the developers at Revo Solutions. So the CogniTwin project is a project that I believe will be vital in the management of dementia patient and in the research in this field, especially in Bulgaria. But first, let me just briefly try to emphasize how important dementia has become in the world, especially recently. As we just heard from the keynote speaker, yes, chronic diseases are on the rise, and I believe this is especially true for dementia. And just in the next slide, I will show you why this is such a problem. But first, there are some other factors that make dementia so significant right now. One of them is, of course, the significant change in the way of life of patients with dementia. This devastating progressive cognitive decline, their loss of independence. And on that note, almost to an almost same degree, this change of life is also valid for their carers. Of course, people with dementia are also a huge financial burden on the public health sector. Dementia is a huge resource consumer in health systems worldwide. And last but not least, moral and ethical issues are also a problem in dementia. And another factor that is important for its significance right now is just that the numbers of dementia patients are rising right now, and this is due to the increased life expectancy. Because as you can see from this chart, increased life expectancy actually leads to increased dementia morbidity and incidence. And this is especially true for the degenerative types of dementia, not so much for the vascular dementia, which is the second most prominent type of dementia. And I believe this slide speaks for itself. As you can see, dementia cases are rising everywhere, but this is especially true for the old continent. And I believe this term is even more true right now. As you can see, until 2050 or 30 years later from now, the dementia patients are expected to rise almost twofold. And now just on why we need to digitalize all this data that we can have from all the cases of dementia patients. Now, first, talking about the national level, we sadly don't have a national register for dementia patients, and this is pretty much a huge problem because a national register really gives a lot of opportunities for better management of the disease and better research. And I believe if the CogniTwin project actually gets on and we play our cards right, I believe the CogniTwin project actually can be a substitute for a national register, or it can actually become the national register of dementia patients. Now, the lack of a national register actually makes it very hard to track patients with dementia, and the responsibility in that case for the management and for the tracking of these patients lies on the shoulders of their carers, and this is not really the optimal version. Another huge problem is that one of the things that can help us in management of these patients is actually cognitive rehabilitation. And this is pretty much practically absent in Bulgaria as well. And I believe in here that the other project that we are working on in collaboration with Revo Solutions and with the Faculty of Mathematics and Informatics, Cognisoft, I believe this is something that can also help immensely. And of course, when we're talking about dementia research is vital because we need a lot more data. Dementia is one of the aspects of medicine that is still, we are a bit helpless there. So research is vital. And sadly in Bulgaria, there is dementia research, but it's very small scale. It's usually done by individual doctors, usually working on their PhD thesis, and this should be done in a more large scale. Also, last but not least, again, I believe that this should be done because looking generally at it, I believe it's very easily done. I mean, all these factors, they can be digitalized because they can be quantified and they can be digitalized quite easily. Now, these are just a few slides and I use the opportunity to thank Associate Professor Petrova Antonova because she's the one who made them. This is just a brief overview of the CogniTwin project, the software, and actually in here, I just want to emphasize that we aimed at being quite comprehensive in bringing as much factors as we could, because this, I believe, could be important in the future, and we could make correlations with many aspects of the lives of these patients. So these slides will actually just show the main clusters of factors that we try to collect, and I will just show them briefly one by one. First, we have the anamnestic data that we have from patients, and this is includes the social state of patients, most importantly where they live, in what type of of town or city, and I believe most important if they are alone or they have carers with them. Also their habits, and this includes and not limited to smoking, drinking, sleeping habits, as well as presence of traumas in the past, especially head traumas. Now, the clinical status, this is pretty much the most important aspect, and I will talk about the others in just a few seconds. The test results is the one that I believe will actually be of the most importance, and these include, I believe, everything that is being done right now for the diagnostics of dementia in Bulgaria. First, it's imaging. These are mostly CT and MRI of the head, and the second most important, the neuropsychological assessment and cognitive assessment. These also include tests for anxiety, depression, and so on. Then we have cerebrospinal fluid markers, which is something that is being done in the last maybe 10 to 15 years in Bulgaria, and it's quite vital in dementia research. There's also blood tests, and where this is available, genetic tests. And there is one quite important aspect of factors, and this is the most probable diagnosis. Of course, in here we're just relying on the doctor's main differential diagnosis, because sadly we don't have neuropathology here, which is the one most important factor for determining the diagnosis. But in here we use the how should I say, the most viable diagnosis in each patient, starting with Alzheimer's disease, of course, as this is the most common type of dementia, then vascular dementia, also mixed dementia, and then going to the rarer ones, Lewy body dementia, frontotemporal dementia, Parkinson's dementia, and Parkinson plus syndromes, which are the rarest type of diagnosis in these cases. Then last, we really found it important to include all the types of medication that the patients take, because I believe this is something that should be correlated with everything else that is put in the software. This includes prescription for cognitive disorders, for vascular disorders, also antiplatelet and anticoagulant drugs, where these are needed, neuroleptic and antidepressants, and sleep medication. So this pretty much includes almost everything about what we are doing both diagnostically and therapeutically in people with dementia in Bulgaria. So with that, I would like to thank you for your attention.
Thank you, Dr. Kunchev. This is indeed an interesting and I would say a comprehensive project and a study that you are running there. And we are running out of time. However, I would use the opportunity to eat a little bit from the break and ask you a question or two. To all of our panelists, from your point of view, what is the single most important piece of technology or algorithm or method or methodology that did not exist a few years ago, but is available now and that made the most difference in your line of work? Trying kind of to track the progress before the obvious next question, what happens next, but or maybe I can start, but let's see if anybody else.
Well, maybe from my own point of view, and I believe this is quite different from all the other panelists, I believe it's just the scope that we didn't have before. That big data that at least for me is new for the last maybe 7 to 8 years, because just like I said in my presentation, of course we all have these doctors that want to do research, and they do it, but what usually happened in the last 10 years in Bulgaria, they just get a group of, let's say, 100 patients, and they do statistics on that, but we need more. We need that big data and that large scope.
Indeed, for a small number of patients, we do not have what is called a statistical power in order to be able to determine informative factors or events. So if anybody would like to, Frederick?
I would just like to chime in there with Turner. I don't think the biggest advancements that have enabled the sort of AI in health progress of recent years, the biggest achievements haven't been in the technological side. The technology has been around for a while. But there's been a lot of work and getting good annotation and good data sets and combining that with existing technology, which admittedly has been advanced. I don't want to take any sort of credit away, but it's a huge number of small pieces that have come together in my mind.
Okay.
And then I will be a little bit more practical.
Mm-hmm.
For me, the most important thing is the mindset of the people. Because we know that from technology point of view, everything could be done. But the biggest problem now is that most of the people in our sector are not aware of the things that could be done. And this is the main problem, and this is the main bottleneck of all this digital transformation that is not happening, indeed.
Okay, thank you. If I could answer the same question, for me, it is the abundance of easily available computational power, especially with the cloud technologies. Prior to that, one would need an access to a supercomputer, and now if you need to run heavy computations for a short period of time, you can deploy a lot of relatively cheap resources on the cloud. And the final question, what happens next from your point of view, in your domain? What do you think would be the major innovation or achievements in the next, say, couple of years or 5 years?
Oh, in my point of view, I believe, especially in Bulgaria, because I would speak on the national scale, there is one challenge ahead, and before we reach that progress we're talking about, I believe we need to overstep one specific conservative feature that we have in Bulgarian hospitals, and I believe the hard part is going to be to make as many hospitals as possible to collaborate on these projects. And I'm a bit I'm a bit skeptical about this happening too fast in Bulgaria. So this is something that I worry about.
But given the fact that we are a little bit behind the more developed countries, perhaps some speed up is needed.
Of course, and this is actually the reason why we are behind. So I hope we overcome that faster.
Yes.
I think from my perspective, one of the exciting things about the recent years in the AI development and machine learning development is that things are now moving into application much more than they have previously. But that's also one of the scary things. We are now faced with problems that we never had before, which are related to sort of robust deployment and transfer of systems to domains that they were never applied in. So I think a lot of exciting research will be more on the sort of engineering side and making sure that systems work well in practice. Yeah, I hope that will be taken seriously, basically. Yeah.
Thank you.
And from my perspective, I see that in the very near future, new value chains will be created based on the patient journey. And in this way, all these silos will be broken. And this is quite much supported by the European Union. So I think that in the next couple of years, we will move in that direction.
Okay, thank you. and to follow up on that, the personalized medicine or the patient journey is perhaps what would follow. The equivalent of that, customer insights and customer journey, exists for many years in different industries. And indeed, it seems to be coming into the digital health domain and to the healthcare system. So with that, I would like to thank all of our panelists, also to our keynote speaker, and to apologize to the audience for running a little bit out of time. And I do believe that the next session will start in about 4 or 5 minutes. Thank you, everybody.
Thank you very much.
Thank you so much.
Okay, thank you. Thank you for all of you. It was a very interesting discussion, and thank you for Dr. Kunchev for his time, because I know he's in a COVID section and he has a lot of responsibilities, and we are all with you and supporting you, and thank you for your participation. And I believe that having this digital innovation cluster, so with collecting different stakeholders, will move faster towards next steps and exchange data and do some important things in Bulgaria to be part of the European Union and to follow faster the rest of the Europe. So thank you very much for your participation, and so we'll continue collaborating and working together.